Good day, everybody. For today, we will study the domain and range of logarithmic function. Again, class, when you say domain, these are the set of all first element or the x values. And when you say range, these are the set of all the second element or the y values. So what is the domain? So in finding the domain of the logarithmic function, it is important to note that a logarithmic function is defined only for positive values of argument. Thus, the range of a logarithmic function is always all real numbers. These are the steps. Number one, set up an inequality showing the argument greater than 0. And number 2, solve for x. Number 3, write the domain. Now let us have an example. Find the domain and range of the following. Number 1, you have y equals logarithm of x base 2. And since walang kasama ang x dito, our argument will be x is greater than 0. Meaning to say, our domain is the set of all x values such that x is greater than 0. Or we can write this as disordered pair, 0 to positive infinity. And the range, as I said, these are set of all real numbers. Number 2, you have y equals logarithm of x plus 2 base 2. So we have here x plus 2. Therefore, our argument is x plus 2 is greater than 0. Applying the addition property of equality, this will become x is greater than negative 2. So from positive, naging negative 2. Therefore, our domain is the set of all x such that x is greater than negative 2. Or in our ordered pair, it is negative 2 until positive infinity. And our real range is the set of all y values such that y is all real numbers. Next, number 3. You have here logarithm of 2x minus 1 base 3 minus 4. So you have this one, 2x minus 1. Hindi po kasali yung minus 4. Alright, 2x minus 1 is greater than 0. Applying the APE, from negative 1, it becomes positive 1. And then, divide both sides by 2. So 2 divided by 2 is equal to 1. And you have 1 over 2 here. Therefore, our answer is x is greater than 1/2. So domain is the set of all x values such that x is greater than 1/2. Or, in our ordered pair, it is 1/2 until positive infinity. Meaning to say, lahat ng positive numbers. And our range, it is the set of all values such that y is all real numbers. What about if we have this one? You have logarithm of 5 minus 2x minus 1. So our argument is simply 5 minus 2x. Kung ano lang po yung nandito, yun po ang ating argument, is greater than 0. Therefore, you have negative 2x. Applying the addition property of equality, from positive, it becomes negative. And then, divide natin by negative 2. So, as you see, class, we change the inequality symbol. Bakit? If we divide both negative, we have to change the inequality symbol. Again, if we divide negative numbers, the inequality symbol in logarithmic, in argument, change. So, from greater than, it becomes less than. Okay? So, negative 2 divided by negative 2 is 1. And if we divide negative 5 divided by negative 2, it is 5 over 2. Therefore, our domain is the set of all x values such that x is less than 5 over 2. Or you have 5 over 2 until positive infinity. Same range. Our range is the set of all y values such that y is all real numbers. Next, number 5. So we have the given here. Y equals logarithm of 4x plus 8 minus 1 base 1 half. So argument natin, 4x plus 8 is greater than 0. So kung ano lang po yung nandito, yun ang ating argument. And then it becomes 4x is greater than negative 8. Saan galing yung negative 8? So from here, we transpose. From positive, naging negative. Divide both sides by 4. So 4x divided by 4 is x. And negative 8 divided by 4, we have negative 2. Therefore, our domain is the set of all x values that is greater than negative 2. Or, if we write this in ordered pair, it is negative 2 until positive infinity. And lastly, we have the range. So as we all know, range is a set of all y values such that y is all real numbers. Last number, you have y equals logarithm of 2x plus 3/4 minus 1 base 2/3. So therefore, we have to use 2x plus 3/4 as our argument. So you have 2x plus 3/4 is greater than 0. Applying the APE again, from positive, naging negative po ito. Then, you have, cross-multiply natin. 2x times 4, you have 8x. Then, negative 3 times 1, you have negative 3. Again, 2x times 4, you'll get 8x. And then, negative 3 times 1, you have negative 3. Then, divide both sides by 8. So our answer is x is greater than negative 3 over 8. Therefore, our domain is the set of all x values such that x is greater than negative 3 over 8. Or in our ordered pair, it becomes negative 3 over 8 until positive infinity. And same, our range is the set of all y values that is all real numbers.